LR1-7 is about special pairs of angles and the relationship between them. So the first special pair of angles that we're going to talk about is a linear pair. So two angles form a linear pair, then the sum of their measures is 180 degrees. A linear pair has the word line in it. So you can think of it as two angles that come together to join a line. So 1 and 4 are a linear pair. 1 and 2 are another linear pair. 2 and 3 are a linear pair, and 3 and 4 make a linear pair. So any two angles that make a perfect line when they are together. My vertical angles then are the ones that are going to be right across from each other. So 1 and 3, for example, are vertical angles. 2 and 4 are. Sometimes kids like to call 2 and 4 horizontal angles because they're like, oh, but they're not really vertical. We still call them vertical angles. There's no such thing as a horizontal angle. And if they're vertical angles, then they are always, always, always congruent. So they have equal measures. All right, we're going to do an example with that, and my picture's a little bit blurry, but because these are vertical angles, I know that this much and that much have to be equal. So I'm going to start by setting 9x minus 13 equal to 7x plus 17. When I add 13 over, I get 9x equals 7x plus 30. When I subtract the 7x, I get 2x equals 30, and then x equals 15. I'm also asked to find the measure of each angle, so I'm going to take that 15, and I'm going to plug it into one of my vertical angles. I don't have to do both, because I know they're going to be equal. So 15 times 7, I'm at 105, plus 17 more. This angle has to be 122 degrees. Now because these two are vertical angles, this one is also 122 degrees. And then I have a linear pair of angles, and those have to add to 180. So to find angle 1, that piece has to be 180, take away 122, so that angle is 58 degrees. Once I know that one, I know 3 because those are also vertical angles. Complementary angles, remember, add to 90 degrees, so the sum of their measures is 90 degrees. They can be right next to each other, like in this example, or they can be separate and they can still be complementary. Okay? Notice complement is spelled with an E. If you spell it with an I, that just means two angles that are nice to each other. So we're going to do an example with that. I know these are complementary because there's this 90-degree marking in the corner. So I'm going to add these up and set them to equal 90. So 4z plus 3z plus 6 equals 90, which means 7z plus 6 equals 90. So 7z equals 84, and z equals 12. Now I wasn't asked to solve for an angle, but if I was, I would plug that in for z, solve, and then potentially subtract. Supplementary angles are the ones that add to 180 degrees. Okay? Sometimes kids confuse these, but just like before, they can either be snuggled right next to each other and make a linear pair, or they can be totally separate. Okay? If you struggle to remember these, complementary, you can make a 90 out of, with that C. Supplementary starts with an S, and you can make a 180 out of that. Other kids have remembered it by saying, well, C comes first alphabetically, S comes second. So 90 comes before 180. That's how they remember it. Whatever's going to work for you as long as you don't flip them. So we're going to do another example. Again, this is a linear pair, so I know they're supplementary, or they're going to add to 180. So when I rewrite this, I get 4n plus 5 plus 8n minus 5 equals 180 degrees. So 12n equals 180 degrees, which means n equals exactly 15. Again, if I was asked to solve for an angle now, I could take that value and plug it in for whichever angle I was asked to solve for, potentially both, solve for one, subtract from 180, what have you. This year we're also going to do a lot with conditional statements. So conditionals are phrases that are written as if then. So if you do this, then you will do that. If you do your homework, then you will understand the material. If you study for the test, then you will do better on the test. If you show up with a pencil, then you will have something to write with, etc. The if part is my hypothesis, and that's different than how we use hypothesis in a lot of other settings. It's not a guess. We're saying if this thing absolutely does happen, if it's happening, okay? It's not, well, maybe it's going to happen or it could happen, or nope, it's absolutely happening. The then part is the conclusion. Okay, which is a little bit similar to how we use it in other settings because it comes at the end. So we're going to do a little bit of this. We're going to practice. My hypothesis always follows the if part. So if two angles form a linear pair is my hypothesis there. Then my conclusion, the sum of their measures is 180 degrees. My hypothesis in this next one, if you're happy and you know it, then the conclusion is you'll clap your hands. If you finish your dinner, then there will be dessert. Okay, so your hypothesis is always the first part, comes right after if, and goes right up to the then. Your conclusion follows the then and goes to the end of the sentence. We are allowed to flip these though and write a converse statement. So if my conditional is if x then y, my converse is if y then x. So for example, if my hypothesis is if you're happy and you know it, then clap your hands. When I write my converse statement, I'm just flipping the you're happy and you know it and the clap your hands. So I'll say if, and sometimes you have to add words to make it make sense grammatically. So I'm going to add the word you, clap your hands. Then you're happy and you know it. And notice just because it's true one way doesn't mean it's true the other way. So it could be true that every single time that you are happy and you know it, you clap your hands. That's great. But every single time you clap your hands doesn't mean you're happy and you know it. You can clap when you're sad. It's allowed, okay? It feels a little weird, but you could. So just because it's true one way doesn't mean when I flip it, it's true the other way. Another good example of this is if you have parents that are anything like mine, when you were a kid and they said, if you finish all your peas, then you'll get ice cream. That doesn't necessarily mean that if you got ice cream, you finished your peas. Maybe they're pushovers. Maybe your babysitter's in a good mood. Maybe mom is like, you know what, you're right, peas are disgusting. Maybe there's a whole bunch of other situations, right? Maybe you ate half of your peas, you made a compromise, you got half a scoop of ice cream. Great. Just because it's true one way doesn't mean it's going to be true the other way. All right, so we're going to look at some of these. If an angle is a right angle, then its measure is 90 degrees. That's always true. Every right angle has a measure of 90 degrees. Going the other way now, if an angle's measure is 90 degrees, then it's a right angle. That one's also true. It doesn't always have to be true in every single setting that we switch them. But in this case, when we switched them, it still was true. Another example, if two angles are vertical angles, then they're congruent. That's true. Remember, my vertical angles are the ones across from each other. They're always congruent. But if two angles are congruent, they don't have to be vertical angles. So that's false. Because I could have an angle here and an angle there, and they could have the exact same measure and not be vertical angles. This is kind of a big idea. It's something that a lot of kids struggle with. It's something that's going to come back and we're going to practice a lot. So if you're sitting here and you're a little overwhelmed right now, don't worry. It's going to come up again and again before we test on it. Okay? If you struggled with some of the earlier problems, there are some extra practice quizzes on Schoology that you might want to work through that have some of that algebra built into our geometric pictures where you're setting things equal, solving for x.